Hi friends! Today we will focus on pulsed voltage stabilizer, which can be used as a laboratory power supply or charger. Before I start, I will remind that the links below video include the full archive of the project with the schemes. There is a reference to the first part of this video where we talked about auto turn-off for battery charger. Our scheme is tuned to charge car batteries with a voltage of 12 volt. But the stabilizer is versatile and is stable for charging all types of batteries, even for lithium-ion, considering that they have balanced boards. So, let's begin. Charger consists of two parts, a power unit and a stabilizer. The stabilizer is based on the popular TL494 PWM controller, will provide an output voltage from 2 to 20 volts. With output current limit from 1 to 6 amperes. If desired, the current can be increased up to 10 amperes. The charging process will be carried out by a stable voltage and current. It is the best way for high quality and safe charging. The charging current in the circuit will drop and at the end of the process will be equal to zero. So there is no danger of overheating the battery or charger. So that process doesn't require human interference. It is also possible to use this stabilizer in the laboratory power supply. Now let's go to the scheme. This is switching regulator with PWM control, which is much more efficient than conventional linear circuits. The transistor operating in switching mode being controlled by a PWM signal. This reduces the heating. The main transistor is controlled by a low-power transistor. A switch provides a large current gain and unloads the PWM chip. This is essentially an analog of composite transistor. Need a transistor with a current at least 10 amperes. It is also possible to use PNP composite transistor, so-called Darlington transistor. Output voltage regulation is carried out by the variable resistor R9. For the most accurate settings, it is desirable to use a multi-turn resistor, preferable of 0.5 watts. Lower resistor can set the upper limit of the output voltage. Selecting ratio of the resistors R1 and R3 sets the lower limit of the output voltage. For a quick and precise adjustment of the divider, it can be replaced with a multi-turn trimmer with a resistance from 10 to 20 kiloohms. For the current limit is responsible a variable resistor R6. The upper limit of the output current can change the selection of resistor R4. I don't advise to take currents more than 7 or 8 amperes, although you can have also 10 amperes. Note the clear operation of current limit function. Even when we got the short circuit, current is less than 6.5 amperes. It is regulated fairly smoothly if you use multi-turn resistor. A current shunt or a current sensor. Here, I would like to draw your attention to the fact that output and input grounds are separated by shunt. Pay attention to it when assembling. The shunt can be made from a segment of nichrome wire with desired resistance. In my version were used SMD shunts, which can be found on the laptop battery protection circuit boards. Shunt resistance of 0.05 ohms plus minus 50%. For a current of 6 amperes, a shunt copes very well. The choke core is taken from the computer power supply, where it was choke of the group stabilization. Winding consists of 30 turns, wound with double wire, diameter is 1 mm each. There is one important point. The number of coils will need to choose depending on the operating frequency of the generator and the magnetic material. Incorrectly value will lead to strong heating of power transistor at high currents. It is easy to understand due to specific whistling at a current of 2-3 amperes. If the whistle is present, it is necessary to increase the operating frequency of the generator. For these purposes, the resistor R2 is reduced to 1 kiloohm and in series to it connected multi-turn trimmer 10 kiloohm. Thus, the oscillator frequency can be changed in the range of 50 to 550 kHz. After setting the desired frequency, demount trimmer, measure its resistance, add to that value 1 kΩ and replace by a fixed resistor, close to that result resistance. This completes the setting. For VD1, highly recommended using Schottky diode with voltage no less than 60 volts and a current of 10 amperes. At currents of 3 to 4 amperes, heat is almost not observed. If want higher currents, must use heatsink. Also possible the use of conventional pulse diode with the desired current. As a power source can be switching power supply or mains transformer with rectifier and a smoothing capacitor. In both cases, a constant voltage power supply should be at least 16 to 17 volts and a current up to 10 amperes. In this project, the simple electronic transformer circuit has been used, about which we will speak in the next video. Also, we will assemble and install the board in the comfortable housing. Now I have to say goodbye. In the description you can find links to purchase not expensive but rather quite good chargers. Download the full archive of the project as well as a link to the first part of this video. If you liked the video, don't forget thumbs up and share with friends. Thanks for watching. Have a nice day. Goodbye.